This is RapidMiner. We've opened up, and we'll start by, I'm just going to a blank project. You can see we've got a bunch of options here. What we're actually going to use is this called auto model. So I've already brought the data in here. This is our loan data. And now we just have to click through here. So the first thing it's going to ask is what do we want to do? Okay, we actually want to predict. What do we want to predict? We want to predict this column. Right, so out of the total 5,000 people, 408 accepted, the rest declined or did not accept. So now we give this option of which variables we want to include, and it has helpfully classified them for us already. So it's saying this ID column is not very helpful, which is good because the ID does not mean anything. This do you have a CD account, it's saying is not very helpful, so we can go ahead and exclude that. It gives some value for age, experience, so zip code is actually not something I want to include because it's not an integer, it's a grouping. Okay. The rest of these we will go ahead and include. So we've now selected 10 out of the available 13 variables. Now it's going to give me a bunch of options for different types of models. I'm going to go ahead and select leave all of them except that last one, that support vector machine. We'll leave it off because it said it would take too long. Okay, and that is all I need to do. Now I'll hit run, and it will begin training these models. So we can see we've got 1, 2, 3, 4, 5, 6, 7, 8 models, or kinds of models it's going to train. Some of these will have multiple models inside of them. And it will give us the performance, so how well does it predict our answer, and how long does it take to do that. So we've got our first answer back, the naive Bayes classifier. It's telling us that this one has an error rate of about 10%. And so far, it's 9.9%, plus or minus 1 percentage point. It took 28 seconds to do the total training. The total time, 24 seconds to train, and only 227 milliseconds to score 1,000. Right, so that was the naive Bayes, but quickly we see that there's a better option. This generalized linear model performs better than the naive Bayes, so let's maybe want to use that. Oh, but wait, there's more. Logistic regression, which is a form of regression that can only have a binary output of 0 or 1, is faster than the generalized linear model. Right? Same scoring metrics here, same probability of being wrong, but slightly faster. So maybe that's what we want to use. What's nice is that we can come over here on any of these and we can see how it, when it did. You can see the weights of the attributes. So for naive Bayes, the age variable was the most important, and experience was the least important. What was really cool is we can come over on the simulator and we can see how these things change. So this is the likelihood that they would accept. Let's increase our experience up here. So I'm grabbing and dragging. That didn't seem to change it much. Let's go ahead and move education up. Oh, still not much change. Let's take the mortgage and bump it up. Whoa, you can see that makes a huge difference here. As the value of the mortgage goes up, the likelihood that they would accept goes up. It also changes the relative importance of the factors. So if we take that, if we bump the income up too, we can see that change. So it's cool is all of these are dynamic and they work with each other. So if you have a low mortgage and a high income, you can see how that would play out. What happens if you have a lot of children or no children? You can see dynamically how it would change for all of these. Then we get a bunch of other metrics like the accuracy, that's how well it's actually classifying things. Then precision is how often is it consistent. So precision recall and score are all related. Those are all just different metrics for classification. You can see here a listing of all of the different ones and the relative importance. You should be able to see, yeah, this is true. Okay, that's the personal loans. This is our predicted value. The confidence that we are right here. So you can see that this one, it got wrong, but it only had low confidence, which is a good indicator that the model's actually identifying that there's something different here. So that was naive Bayes. We can do that for each of these. We can go over to the generalized model, linear model, see the weights. We also have the simulator here. You can see that for this model, the factors are different. It uses different mathematical techniques, and so the ways that it scores things are different. That way, the variables that you have, the importance of them is different. If we come all the way down to the bottom, we can see some general statistics about our data set here. So you can see a histogram all made for us for each variable. We can look at some statistics like missingness. We can also see correlations of the variables. That's calculating still. Let's come back over here. So while we've been talking, it has gone ahead and classified using different models. So it's done naive Bayes, generalized linear model, logistic regression, fast large margin, deep learning. So deep learning is what is really popular right now in the news. That's what the computers that play chess and AlphaGo, that play the game Go, the ones that can play Flappy Birds, they're all using deep learning. So we have just done a deep learning model without having to actually type in any code at all. And we can see so far the deep learning has performed the best. The decision tree was faster. So the decision tree is a much simpler model than a deep learning model, far less going on. And if we look at decision tree, what it's doing is it's breaking apart these variables on different categories. So it started with your credit card average spend. If your credit card average spend is greater than $8,850 a month, then the answer is yes. We can stop there. But for most people, it's less. You can see that's a thin line. So it's showing the number of people who fall in that category. So after it asks the credit card question, it goes to the mortgage question. If your mortgage is more than $566,000, then yes, you get the loan. Otherwise, go down to income. And you can see this is actually a very elaborate tree that it has built all the way down. Each one is a binary question. So are you bigger than this? If yes, here. If not, there. And then another question. You can see we actually have credit card score come back again here as another way of breaking this down. So an income shows up multiple times. This is a very elaborate decision tree. And what we can see here, let's go back to, or still working on that, the random forest classifier takes quite a while to train because it's actually going to be training 140 separate decision trees. The way random forest works is it does a bunch of decision trees, but it makes them smaller. So this decision tree has got a lot of what we call branches. It's very deep, lots of branches. The random forest makes 140 trees that have fewer branches. And then it goes through and does a poll of all of those results for each person, and whichever one shows up the most, like whether or not the answer is yes or no, that's what wins. So random forest is a different way of implementing decision tree, and it's often much more stable, but it does take longer to train. Let's take a look at this chart. At first this is a little confusing, but what this is showing is how good these models are. So what we want to see is models that come up as close to this upper left-hand corner as possible. Right? The higher up here, the better. And it's easy to see that the naive Bayes was not all that great. Most of them are up here. But there is a difference as you move out, that maybe some of the classifiers are different. So this fast margin initially was better than naive Bayes, but actually plateaus sooner. Let's go back to our overview and see how this is going. We're just going to pause and let this finish training and then come back.